to get started, I wanted to do a quick overview of the demo. We'll be using a vacuum infusion process to infuse an automotive car hood today. I wanted to show you the finished part. Thank you. Our Vanna White over here is showing our beautiful piece that we pulled yesterday from the part. Also, an really interesting feature this year is the tooling technology that we're using. This is in fact a mid-scale 3D printed tool that we're using for the demo to infuse on. So with that, I wanted to do about 3 top-level concepts and takeaways for the group this year. A lot of times these demonstrations can be a little challenging because we have to gloss over a number of details. So the 3 basic concepts that I'd say are most valuable in pertaining to the infusion process are pressure differential, resin viscosity, and material permeability.
Neil was talking in his takeaways about permeability, and as you build layer by layer, you want to make sure that there is no permeability into your tool surface, right? You want 0 there. So what we've done is, following the printing, we apply the coating that we've developed, which seals that surface up. It also addresses any print defects and allows you to create geometry that wouldn't be cost effective to create with the printing process itself.
So this particular mold here has our orange tooling gel coat on it from Polent. It's a workhorse tooling gel coat for tooling applications. Our 945 series material on here. It comes in multiple colors as well. As Neil alluded to, critical in infusion for us is the lower the viscosity, the faster the infusion. An example of that is Darcy's Law comes into play here. 400 centipoise viscosity material versus 100 centipoise viscosity material. The 400 centipoise material will take 4 times as long to infuse, all things being equal. So the lower the viscosity, the better the ability to wet fiber, the faster it'll flow through the material as well.
Just for example, an additive that we might recommend for a process like this, specifically the vinyl ester being used for the infusion, would be our BIC A560 product. And BIC A560 is an additive that can be added either by the resin manufacturer or by the end user, and it is going to assist in things like air release and fiber wetting.
You can see from the appearance of the mold, you have a nice gloss appearance, and we have some high build mold sealers that are our MPP 2180. That stands for mold prep and prepare and prep. And with this product on a high build mold sealer, you seal porosity in the tooling and also smooth out the surface roughness so that you get a hard ceramic coating, and then you also get better performance with the release agents and the sealer.
What Mike is spraying on right now, as a number of you probably have seen before, worked with before, is a spray tack material. And so we really try hard not to put the spray tack material on the tool surface. It basically just ends up leaving a residue. Certain spray tacks need to be avoided from a best practice standpoint with infusion. Some of them have quite, basically just a basic rubber adhesive and become a contaminant. So products like the fiber tack and like the new tack from Polent work very well to dissolve in the resin system. So getting back to the layup here, we kind of got an ambitious demo here because we're trying to go through the entire process and speak to each of the materials as we go through the process. So we already started laying down the initial plies of carbon from Vector Ply. And I wanted to start with a layup speaking about the Lantor Soric, which Mike was kind enough to give me a section of. And this is a Soric TF. This one in particular has quite a small, fine cell size, and it gives us a very nice surface finish for tooling and part surfaces, hull sides.
What we're showing off today is we got 3 different products here. As our first layer for that nice carbon fiber twill look, we have a 6-ounce twill material here. The nice thing about this material is on the back side, it's got a very lightweight nylon veil that's been heat set to keep the weave pattern in perfect order. You see here, as most of you know, that you cut a piece of woven this size and you shake it around, it's going to turn into a ball of spaghetti real quick.
And in this case, we're actually doing a combination of a bit of a combination of both, because we have good permeability in some of the carbon plies here, in addition to a surface flow over the top. And essentially, this actually allows us to peel off a lot of the redundant excess resin. So your lighter weight parts are gonna be made with a surface flow medium over the top that gets peeled off. So that's what we're gonna stick on now. We're just laying down now the Enca Fusion line inlet that allows us, it has a very, very large permeability, and what it does is allows for the resin to very quickly run basically down the longest dimension of the part. And this product is called Enca Fusion. We can also use in its place spiral wrap, which a number of you probably have seen before for the infusion process. So Enca Fusion is unique in the fact that it doesn't print very well. It's a very distributed pressure pattern over the laminate, so it doesn't print like spiral wrap has a tendency to do. So we're making sure that the Enca Fusion is in contact with the infusion medium here. Thank you. So inside of the sleeve on the part, we're going to let them bag it up now, and I'll describe the rest later. The basic setup here, we have a couple of accessories from Airtech. We've got a basic peel ply that's used as our resin brake, which I'll speak about a little bit later. We've got our vac rick, which is the fitting that's running, that we put our hose through the bag with. That's the vac rick. And we have a little bit of spiral, our vacuum manifold, communicating to the peel ply. And it becomes a very much more conservative infusion setup that will even out the flow and help prevent flow wraparound, dry spots, closeouts, okay? So again, that kind of speaks to the tool design. I've got my vacuum line running through. In this case, I have it running through my sealant tape. You can also do a vacuum through the bag with another vac rick located on this side. But now that we've done the bagging operation, Mike and Rick did a phenomenal job. Thank you so much for bagging that up. It's a little bit tricky even when you don't have 50 people watching doing a bagging operation. So I really appreciate that, guys. Again, I knew it was a bit ambitious, but I wanted to see everybody. I wanted to have everybody see the process from the ground up. The trick with bagging is to do a nice light touch in case you have to, yank the bag back up again, and then go back around once you finish your bag and you feel comfortable with everything. And so now I'm going to basically the vacuum drop that I usually find is appropriate. At least it's a bit ambitious, but I try and go for about a 1/2 inch of mercury drop in about 5 minutes. And that's a fairly decent, that's pretty stringent actually as industry goes. But but as aerospace goes, in fact, you're talking in the realm of 20 thousandths of an inch in 5 minutes. So significantly more, accurate, stringent vacuum drop regulations. So essentially what a good vacuum integrity and a good vacuum bag will give you a much more repeatable part. Basically a single strand of carbon has very tight filaments, and so it tends to have very low permeability, and it's quite challenging sometimes to permeate into, as you can see, the flow front coming across the part now. Keep watching that as it goes. But that low permeability value is something that you really need to be aware of when you're doing thick carbon parts. This is a relatively thin carbon part, so not as important. But if you're doing a thick carbon part, best practice, please try and remember to pull back your infusion medium as well. And what that will do is not only will it even the flow front out on an XY plane, but it will also even your flow out on the Z axis as well, and permeate through more evenly so that you don't have the potential of a dry spot through the thickness of the carbon layup. So that's what we did here, is we pulled back our infusion medium slightly. We've got plenty of gel time. This is quite a large infusion medium break. Normally with a part this size, I would probably only have about, say, 1 inch break all around the perimeter. Again, it's on the sides as well that you want to keep the infusion medium short. So the nice thing with the CompaFlex as well is that it's best practices also with carbon, because it takes a little bit longer to saturate, to actually have a slower infusion medium. And so CompaFlex actually offers this yellow version. It also offers a white version that's quite a bit slower, which actually works in your favor. When you start with infusion, you want everything to just go as fast as possible, you know, and shoot everything as fast as possible. But sometimes the slow infusion works in your favor for cosmetics and for better saturation of the fibers. So that's actually what's happening here. We have a nice flow front speed progressing across a little more even. I wanted to be a little bit more uneven to show you how it evens out.